Hi students, welcome to Sunil's tutorial. I am Sunil Milwani and today we will be doing this chapter called as current electricity. Please take down the sum, guys. All of you please take down the sum. Take down the sum as I dictate. Right, a conductor has a diameter of 0.4 millimeters. A conductor has a diameter of 0.4 millimeter and resistivity of 5 into 10 raised to minus 7 ohms. And resistivity of 5 into 10 raised to minus 7 ohm meter. 5 into 10 raised to minus 7 ohm meter. If the resistance is 40 ohms, find the length of the conductor. Find the length of the conductor. Now, guys, let's see this. If diameter, let's please pay attention. If the diameter is given to you as 0.4 millimeters, then the resistance will be diameter upon 2, that's 0.2 millimeters. To convert from millimeters to meters, you have to multiply by 10 raised to minus 3. Okay? Now, R resistance is given by the formula specific resistance into length divided by cross-sectional area. Right? So I can say R is equal to rho L by A, area of a wire. The cross-sectional area of the wire is a circle. If I take, so that would be pi r square. Therefore, I can say that R into pi r square upon rho is equal to L. If I cross multiply, in which case I'll get L is equal to R, 40 into pi, 3.14 into R, 0.2 into 10 raised to minus 3 the whole square upon rho is 5 into 10 raised to minus 7. Right? When you solve this equation, you will get the answer for length as 10.048 meters. So the length of the wire will be 10.048 meters. Next, take on next sum please. A resistor of 25 ohms. Is connected to a cell. A resistor of 25 ohms is connected to a cell having an internal resistance of 3 ohms. Find the current and the terminal potential difference. Find the current and terminal potential difference. Guys, I'll just read the sum once again. A resistor of 25 ohms, I think I didn't dictate this, a resistor of 25 ohms has is connected to a cell of EMF 4 volts. Is connected to a cell of EMF 4 volts. Has an internal resistance of 3 ohms. Find the current and terminal potential difference. Is connected to a cell of EMF 4 volts. Right? Now, I can say that I is equal to E upon R plus R. So I can say current is equal to 4 upon R, that's 25 plus internal resistance 3. So I is equal to 4 upon 28, right? Once you have this will give you the answer for I as 0.0 142 amperes. Once you have this, then I can find out terminal potential difference. V is equal to E minus IR. Either I could do it by this formula or there's another method of doing it. I'll show you. E is 4 into 4 minus I, 0.142 into internal resistance is 3. So this is 4, 6, 12, 4. Right? When you subtract this, you will get the answer as 3.57 volts. Right? Did you get this thing clear? So that will be your terminal potential difference. Take on next one, please. A resistance of alloy at 0 degrees, resistance of alloy at 0 degrees is 25 ohms. Resistance of alloy at 0 degrees is 25 ohms. And the temperature coefficient of the alloy is 0.0007 per degree Celsius. Calculate the resistance at 10 degrees centigrade. Calculate the resistance at 10 degrees Celsius. Now, I can use the formula RT is equal to R0 1 plus alpha T. So I can therefore say that 25 1 plus 0.0007 into 10. So this is going to be 25 1 plus 0.007. This is 25 into 1.007. When you multiply this will be nothing but 25.17 ohms. So the resistance will be 25.17 ohms at 10 degrees Celsius. Next, take on next one, please. Calculate the work done. Calculate the work done in moving a charge. Of 6 coulombs. In moving a charge of 6 coulombs from a point. In moving a charge of 6 coulombs from a point of 10 volts to a point of 100 volts. From a point of 10 volts to a point of 100 volts. They've given you the potential of 2 points. Therefore, the potential difference between them will be 100 minus 10, that is 90 volts. Right? They've asked you to find out work. Work is nothing but V into Q. So that is 90 into 6, 6 9s are 54, 540 joules of work is done. Take on next one, please. A resistor of 10 ohms. A resistor of 10 ohms is connected to a cell. A resistor of 10 ohms is connected to a cell of 12 volts and draws a current of 0.9 amps Find the internal resistance of the cell. Find the internal resistance of the cell. Find the internal resistance of the cell. I can say that I is equal to E upon R plus R. So I could say that I, that's 0.9, is equal to 12 upon R plus R, cross multiply. 10 upon R is 12 upon 0.9. Therefore R is 12 upon 0.9 minus 10. When you solve this, you will get this answer as 3.32 ohms. So the internal resistance of the cell is 3.32 ohms. Take on next one, please. 3 cells of EMF, 3 cells of EMF 1.5 volt each, and 2 cells of EMF 1.2 volts each are connected in series. Calculate the battery voltage. Calculate the battery voltage. Right? So your battery voltage will be, since they are connected in series, that will be just the simple addition of all 5 of them. V4 plus V5. All you have to do is add all of them. When you add them, you will get the answer as 6.9 volts. So the total EMF when those 5 batteries are connected in series is going to be 6.9 volts. Next, take our next one, please. This is 4.5, 5.5, 6.5 plus 0.4, 6.9. Right? Next, the rating of 3 cells. The rating of 3 cells is 12 volts, 500 milliamps. The rating of 3 cells is 12 volts, 500 milliamps, and are connected in parallel. Calculate the current rating of the battery. 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 Guys, just make a correction in the sum. Instead of 3 cells, make that as 2 cells. The rating of 2 cells is 12 volts and 500 milliamps. Okay. Now, since the cells are connected in parallel, therefore the battery voltage will be the same as the rating of any one of the cell. Battery voltage, since they have same voltage, battery voltage of the cell will be equal to rating of any one cell. So that will be 12 volts, right? Since they are connected in parallel, the current rating will be the sum of the currents drawn from each of the battery. So that is 500 milliamps plus 500 milliamps. That will be 1000 milliamps, which is nothing but 1 amp. So the current that will be drawn from the battery is going to be 1 amp, right? Take on next one, please. A heater is connected to 240 volts and draws a current. A heater is connected to 240 volts and draws a current of 3.5 amps Calculate the heat dissipated in 15 minutes. Calculate the heat dissipated in 15 minutes. Now first of all, just convert these minutes into seconds, that is 15 into 60 seconds. Heat is equal to VIT joules. Since they have asked me heat dissipated, I need to give it in calories. This is nothing but VIT upon 4.2 calories. That's how you convert from joules to calories. So now I need to substitute the values 240 into 3.5 into 15 into 60 divided by 4.2. Right? Do your calculation. You should get this answer as 1.8 into 10 raised to 5 calories. Fine, do we get this? Right, next, take down the next one, please. A metal wire has a diameter of 0.6 millimeters and resistance of 30 ohms. A metal wire has a diameter of 0.6 millimeters and a resistance of 30 ohms. Find the length of the wire if the resistivity is 3.8 into 10 raised to minus 7 ohm meter. Also calculate the potential difference. If a current of 800 milliamps flows through it. Right? First thing you have to do is convert milliamps to amps. How do I do that? Multiply by 10 raised to minus 3. Now, they have given you diameter 0.6 millimeters, so I can say radius is diameter divided by 2. 0.6 divided by 2, that is 0.3 millimeters. To convert from millimeters to meters, you multiply by 10 raised to minus 3. Now I can use the formula R is equal to rho L by A. They have asked you to find out the length of the conductor. Now where A stands for the cross-sectional area. Area of a wire, cross-sectional area of the wire is going to be a circle. So you will get R is equal to rho L upon pi R square. Therefore I can say L cross multiply R pi R square upon rho. Resistance is 30, pi 3.14, radius 0.3 into 10 raised to minus 3 the whole square upon rho, resistivity 3.8 into 10 raised to minus 7. Solve the equation. When you solve the equation, you will get this answer as 22.3 meters. So the length of the wire is going to be 22.3 meters. Now in the sum they have also asked you to find out, they said that calculate the potential difference. I can find out the potential difference by using Ohm's law. V is equal to IR. Current they have given you is 800 milliamps. So that's 800 into 10 raised to minus 3 into resistance. Resistance is 30 ohms. 8 3s are 24 into 10 raised to minus 3. So this will be 24 volts. So potential difference will be 24 volts. Fine, do you get this thing here? Next, take on next one please. A uniform circular wire has a resistance of 15 ohms. A uniform circular wire has a resistance of 15 ohms. If the length of the wire is doubled, by stretching it, what will be its mu resistance? Now guys, let's see this. Let R1, L1, A1 be the original resistance, length and area of the cross-sectional wire. Let R2, L2 and A2 be the new resistance, length and cross-sectional area of the wire. Now, since the same wire is stretched, therefore I can say that rho will remain constant. Rho will be same for both the wires. Now I could say that R is equal to rho L by A. Similarly, I could also say that R2 is equal to rho L2 by A2. Right? Divide the two equations. So therefore I can say R1 upon R2 is equal to rho L1 upon A1 divided by rho L2 upon A2. Rho and rho gets cancelled. So I'll get R1 upon R2 is L1 upon L2. Denominator of denominator becomes numerator. So that will be A2 upon A1. Call this as equation 1. Now I can say that even if the wire is stretched, its volume will remain constant. Even if the wire is stretched, its volume will remain constant. Now, that means, how do I find out volume? Volume is nothing but area into length. So that means initial volume should be equal to final volume. That means A1 into L1 should be equal to A2 into L2. Therefore, I can say that L1 upon L2 is equal to A2 upon A1. Let's call this as equation 2. Right? They have given you that the length of the wire is doubled. That means they have given you that L2, guys, let's see the data. They have given you that L2, the length of the wire is doubled. L2 is twice L1. Right? Now substitute equation 2 in equation 1. Substitute equation 2 in equation 1. So So I'll get R1 upon R2 is L1 upon L2. Instead of writing A2 upon A1, I can write L1 upon L2. Therefore, I will get R1 upon R2 is L1 square upon L2 square. Right? The R1 we know is 15 upon R2 is L1 upon L2 the whole square, but L2 can be written as twice L1, so 15 upon R2 is L1 upon twice L1 the whole square, cancels, so cross 1 upon 2 the whole square, so I can say 15 into 4 is R2. How did I get 4? 2 square is 4, cross multiply. So R2 will be 60 ohms, right? So if the length of the wire is doubled, the resistance will be 60 ohms. Fine. Take on the next one, please. A copper wire has a resistance of 30 ohms. A copper wire has a resistance of 30 ohms at 30 degrees Celsius. A copper wire has a resistance of 30 ohms at 30 degrees Celsius. The resistance is increased to 40 ohms at 400 degrees Celsius. The resistance is increased to 40 ohms at 400 degrees Celsius. Calculate the temperature coefficient of resistance. Calculate the temperature coefficient of resistance. Let us assume that R0 is resistance at 0 degrees Celsius. Now I can say that R1 is equal to R0 1 plus alpha T. Right? Similarly, I could say that R2 is equal to R0 1 plus alpha, this was T1, this is alpha T2. Divide equation 1 and 2. Divide equation 1 and 2. If I divide equation 1 and 2, I get R1 upon R2 is R0 1 plus alpha T1 upon R0 1 plus alpha T2. R0 gets cancelled. Therefore, I could say that R1 upon R2 is 1 plus alpha T1 upon 1 plus alpha T2. Right? Substitute the values. You have the values with you. So I can say 30 upon 40 is 1 plus alpha into T1. 30 upon 1 plus alpha into T2. That's 400. So 30 into 1 plus 400 alpha is 40 into 1 plus 30 alpha. So you will get 30 plus 4 3s are 12 is equal to 40 plus 4 3s are 12, 100. Right? Solve the equation. When you solve the equation, you will get the value of alpha as 9.25 into 10 raised to minus 4 per degree Celsius. Take down next one, please. Three wires of equal length. Three wires of equal length. Three wires of equal length are made up of the same metal. Three wires of equal length are made up of the same metal. Three wires of equal length are made up of the same metal. Their diameters are in the ratio of their diameters are in the ratio of their diameters are in the ratio of 1:3:5. Their diameters are in the ratio of 1:3:5. The three wires are connected in parallel. The three wires are connected in parallel. Three wires are connected in parallel. Calculate the current. Calculate the current in each wire. Calculate the current in each wire if the total current is 40 ampere. Calculate the current in each wire if the total current is 40 amperes. Right? Let's see the sum, guys. Let us assume, let R and D be the radius and diameter of the wire. Right? Now, cross-sectional area of the wire, cross-section is circle. So, cross-section area will be pi r square. But area is nothing, radius is nothing but diameter divided by 2 the whole square. So I can therefore say that A is equal to pi into d by 2 the whole square. We also know that R is equal to rho L by A. Therefore, if I consider rho and L to be constant, then I can say R is inversely proportional to A. Therefore, I could say that R is inversely proportional to pi d upon 2 the whole square. Pi is constant, 2 is constant. Therefore, I could say that R is inversely proportional to d square. Right? Do we get this thing here? Now, but they have given you that d1 is to d2 is to d3. The ratio of the diameters is given to you as 1:3:5. Right? Do we get this thing clear? That means I can therefore say that R1 will be R, R2 will be, I can say that R1 is 1 upon d1 square, is directly proportional to 1 upon d1 square. So R1 is directly proportional to, let's assume that this is 1 upon 1. R2 is directly proportional to 3, 9. Wait. I'll just do this. Let's find out the ratio of the resistance. Now, the ratio of the resistance let's see the ratio of the resistance. How do I get the ratio of the resistance? I want R1 is to R2 is to R3. We have already said that it is inversely proportional to D square. So let us assume that this is going to be 1 is to 1 upon 9 is to 1 upon 25. Guys, how did I get this? R is inversely proportional to D square. So this will be 1 upon 1 square, 1 upon 3 square, 1 upon 5 square. Right? So 1 upon 1 square is 1, 1 upon 3 square is 9, 1 upon 5 square is 25. Now they have said that they have been connected in parallel. Let Rp be equivalent resistance in parallel. Now when resistors are connected in parallel, then resistance is given by the formula 1 upon Rp is 1 upon R1 plus 1 upon R2 plus 1 upon R3. Right? In that case, I could therefore say that 1 upon Rp is 1 upon R, where I am assuming R to be the common factor in the ratio of resistance, plus 1 upon R upon 9 plus 1 upon R upon 25. So this will be 1 upon R plus 9 upon R plus 25 upon R. Denominator of denominator becomes numerator. So this is going to be 35 upon R. 1 upon Rp is 35 upon R. Therefore, I can say that the equivalent resistance in parallel will be R upon 35. Now, they have also given you that the potential difference is given to you as, no, they have given you the current. The total current is 40 amps, right? Now, since the wires are in parallel, therefore, I can say that potential difference will be constant if you have the wires, or if you have resistors in parallel. In a parallel circuit, the potential difference is constant. Therefore, I can say that the potential difference in each wire will be the same. Potential difference will be nothing but current, Ohm's law, into R1. Current is given to you as 40 amps. R1. Now R1 is given the resistance, equivalent resistance is given to you as R upon 35. So that means the potential difference in each wire will be nothing but 8 upon 7 R. That will be the potential difference that will be applied to each wire. Therefore, I can say that current flowing through each wire, I1, let's assume I1 is the current that is flowing through the first wire. I is nothing but V upon R, again by Ohm's law. So V upon R1, V. We've just found out the potential difference to be 8 upon 7 R, and the ratio of R1 is R. So I1 is 8 upon 7 amps. Similarly, I can say I2 is V upon R2, that is 8 upon 7 R divided by R2. R2 is nothing but R upon 9, right? So in that case, this is going to be 9 8s are 72 upon 7 amps. Similarly, I could say that I3 is V upon R3, so that is 8 upon 7 R divided by R by 25. Right? So in that case, this is going to be 25 8s are 200 upon 7 amps. So this will be the current that will be flowing through each wire. Let's see one more sum, guys. Have you all copied the first column? Has everybody copied the first column? Guys, everybody has copied this first column. Can I rub the first column out? Right? One last sum I want to do to finish off this chapter, guys. Right, take down the last sum please to finish this chapter. A house has 60 watt 10 bulbs. A house has 60 watts 10 bulbs. W-A-T-T, watts, however you may say it. A house has 60 watts 10 bulbs. 100 watts 4 fans, 40 watts 8 tube lights, 100 watts 4 fans, 40 watts 8 tube lights, 40 watts 8 tube lights, and other appliances consuming 1500 watts, and other appliances consuming 1500 watts. Each day on an average, 4 hours supply is used. Each day on an average 4 hours supply is used. Find the total energy consumed in joules. Want water? Want water? Find the total energy consumed in joules in kilowatt hour. Find the total energy consumed in joules in kilowatt hour. Find the total energy consumed in joules in kilowatt hour. If the cost of 1 kilowatt hour is 3.2 rupees, if the cost of 1 kilowatt hour is 3.2 rupees, find the cost of electric energy consumed in a month of 30 days. Find the cost of electric energy consumed in a month of 30 days. Now let's see. What is the power consumed? They are saying that a house has 60 watt 10 bulbs. Power consumed by 10 lamps. The power consumed by 10 lamps, there are 10 lamps, each lamp is consuming 60 watts, so that will be 600 watts of power will be consumed by the 10 lamps. Then you have 4 fans, so each fan, the total power consumed by the fans, each fan is consuming 40 watts, so that is 160 watts. Then it has got 8 tube lights. Each tube light consumes 40 watts again. That's fans are not of 40 watts, fans of 100 watts. So that is 400 watts. Tube lights of 40 watts, which is going to be 320 watts, right? And you have other appliances. Other appliances are consuming, they are saying 1500 watts. So the total power consumed is going to be the addition of all of them, 1000, 2500, and this is going to be 2820 watts. This is going to be the power consumed in 1 hour. Okay. Now, in a day, they are saying that the supply is used for 4 hours. So what will be the energy consumed per day? Right? In 1 hour I am consuming 2820 watts. In 1 day I am using the appliances for 4 hours on an average. So the energy consumed per day is going to be so many watts. Now these many watts. Since I have to pay electricity bill, I have to convert this into joules. Now before I do that, this is 4 hours. I'll have to convert that into seconds, so 2820 into 4. To convert from hours to second, I have to multiply by 3600. So this can be written as 4.06 into 10 raised to 7 joules. This will be the energy consumed by the appliances per day. We have 30 days in a month. So what will be the energy consumed per month? Is going to be 4.06 into 10 raised to 7 multiplied by 30, right? This is going to be nothing but 12.18 into 10 raised to 8 joules, right? Now 1 kilowatt hour is nothing but 3.6 into 10 raised to 6 joules. That's the conversion factor. 1 kilowatt hour is 3.6 into 10 raised to 6 joules. Therefore 12.18 into 10 raised to 8 joules will be how many kilowatts hours? So when you cross multiply this, you will get the answer of X as 12.18 into 10 raised to 8 upon 3.6 into 10 raised to 6. This comes to 338.4 kilowatt hour, right? Once you have done this, they tell you that the cost of 1 kilowatt hour is 3.2 rupees. Cost of 1 kilowatt hour is 3.2 rupees. Okay. Therefore, what will be the cost of 338.4 kilowatt hour? It will be nothing but 338.4 into 3.2. When you solve this, this will come to 1082.88 rupees. So that will be the electricity bill for the month. That's how you calculate your electricity bill for the month. This finishes this chapter. We'll stop here for the day. Thank you very much.